The maximum number of acute angles in a convex tengon in the Euclidean plane is 1, 2, 3, 4, or 5. So I think what I want to do here is work out what is the sum of the interior angles of a tengon, and see if I can find like something there. I mean, I'm drawing a hexagon, but the sort of method that I'll use here will be the same. The idea here is these angles all add up to 360. So the sum of theta I, as I goes from 1 up to 10, this has to equal, I'll write it as 2 pi. And of course, these are the exterior angles. Those are the things that I'm calling theta. So that's theta 1, theta 2, theta 3. And if I call the interior ones alpha 1, alpha 2, alpha 3, and so on, well, I have alpha I is equal to pi minus theta I. Or in other words, theta I is equal to pi minus alpha I. So this says that the sum, I goes from 1 to 10, of pi minus alpha I is equal to 2 pi. So now, so this is the same as 10 pi minus the sum, I goes from 1 to 10 of alpha I is equal to 2 pi. So I have the sum of the interior angles is 8 pi. Okay. And all of the alphas, I guess they're going to be strict inequalities here. Each of the alphas is between 0 and pi over 2. Not pi over 2, pi. Right? But I want to ask myself, how many can be less than pi over 2? Yeah, that's all the angles are between 0 and pi, but the ones that are less than pi over 2 are the ones that are acute. So if I have 5 that are less than pi over 2, suppose alpha is 1 to 5, alpha 1 up to alpha 5 are less than pi over 2. Then I have the sum, I goes from 1 to 10, of alpha I is less than 5 times pi over 2 plus the sum, I goes from 6 to 10 of alpha I. And this is see, 16 minus 5 pi over 2 is less than the sum, I goes from 1 to 6, or 6 to 10 of alpha I. So 11 pi over 2 is less than I equals 6 to 10 of alpha I, and this is a contradiction because the maximum value of these alpha i's is pi. So the maximum value of this is 5 pi, and this is greater than 5 pi. So it's not possible to have 5 acute angles in this convex tengon. Let's try with 4. 4 is probably going to work. Suppose alpha 1 up to alpha 4 are less than pi over 2. So then I have that 8 pi is equal to the sum of all 10 angles. But if I replace the first 4 with pi over 2, then that's 4 times pi over 2 plus the sum I goes from 5 to 10 of alpha I. So on the left-hand side, I have 6 pi less than the sum I equals 5 to 10 alpha I. This is still a contradiction, isn't it? Because these cannot be, each alpha I, its largest value is pi. Well, no, it doesn't have a largest value. It must be strictly less than pi. And if these are strictly less than pi over 2, then this is true. But that can't be true. Or what if, hold on. Hold on a second. What if alpha 1? So let's let gamma equal 8 pi over 10, which is 4 pi over 5. This is the standard. Oh. Yeah, no, I think again this can't work. This is going to be a contradiction. Just a minute, hold on. Alpha 1 up to alpha 4. Let's call this pi over 2 minus epsilon. So then the sum of those 4 alpha I is going to be 2 pi minus 4 epsilon. So then what I could do is say that the remaining angles they have to add up to 6 pi plus 4 epsilon. Yeah, and that's not that's not possible. Okay, so the answer is going to be 3 then. It's clearly like we're right at a boundary case. We're right at a boundary case where we just barely cannot have 4 acute angles. We're right on an edge. So you can construct a tengon convex with 3 acute angles. And if you kind of just go through this whole thing again, you'll end up with something like this, but it won't in any way be a problem. There won't be a contradiction like there is here. So yeah, nice little problem. Something I never thought about. I didn't realize that there were restrictions on how many acute angles could be in, but I guess that makes sense. I'm just trying to visualize some other shapes. Like this is probably true for, I mean, it's not just a 10-gon, right? This will be true for smaller. Will it be true for smaller ones as well? Like triangle obviously can have 3. You cannot have a quadrilateral with 4 acute angles. Can you have a quadrilateral with 3 acute angles? No, because the inside's well, hold on. Yeah, ugh. 1, 2, 3. Yeah, so there's 3 acute angles in a quadrilateral. Yeah, I've never thought about this before, but that was a nice one to figure out. If I find a mistake or have more to say, I'll put it down in the description. Thanks for watching.